Okay, hello students, my students and students of the world. Welcome once again to another session with Mr. D's math class. And today we're going to be looking at, in our textbook, the ones that I'm working with my students, it's called 3.5, dividing whole numbers and fractions. So let's begin with an example, but basically what we're going to do here is we're going to model whole numbers, dividing whole numbers and fractions on a number line. But I will also probably do a little bit of modeling with, circles, diagrams, etc. So let's jump in our first example here. So here's our first one. And we did do this in class, and we did try to record a YouTube video during class, but it was just little too much distraction, and sometimes I have to walk away from the camera. So hopefully this one will work even better. I told my students, when you're looking at a division, especially with fractions, you really have to look at it as interpreting division in another way. Okay, so originally, the word divide, some people will think it means take something and split it up. Okay. For example, sometimes people would think of division as 6 divided by 3. Well, they want you to take 6 and then divide it into 3, or split it into 3 parts, in which case each part is going to have 2. So to illustrate that, this is called actually a set model. If you're going to divide this 6 into 3 equal pieces, 3 equal parts, well, here they are. There's 1 part, 2 parts, and 3 parts, and where each part is going to have 2. Okay, so this is probably the original way that the word divide was taught in earlier years. But in this case, when we're talking about fractions, I really want people to try to understand that sometimes divide can also mean a different way. Okay, so in the example that we gave here, 6 divided by 3, you can really interpret this as, well, it'll be a longer sentence. Divide can actually, in this case, 6 divided by 3, can actually ask you how many 3's are in 6. Okay? So whether this is a new way to interpret division, or you've always understood a division can mean this way, that's what we're going to use. Actually, that's much more useful when we talk about dividing fractions. Okay? So in our first example, if we want to actually interpret 2 divided by 1/3, this really is asking how many 1/3s are in 2. Okay? And from here we can actually model this. So the first way, I'm going to model on a number line, because our assignments actually ask you to model this using a number line. So here's my whole numbers, 0, 1, and 2. And from here, you might ask, well, how do I know what fraction I should divide each of these whole numbers from 0 to 1 and 1 to 2? Well, the only fraction I gave you here is thirds. So we're going to divide those into thirds. So now we have 1/3, 2/3, 3/3 is equal to 1. We're going to divide 1 to 2 into thirds, and now everybody is in thirds. And so now, here is asking, each of these notches are 1/3 each. And now we're going to answer this question, how many 1/3s are there in 2? Well, this is 2, and now we're just going to count 1/3s. This is 1/3. There's also 1/3, in this case 1 1/3, 1 2/3. So here's a 1/3. This is also 1/3, so that's 2. Another 1/3, that's 3. Another 1/3, that's 4. Another 1/3, and that's 5. And another 1/3 will give us 6. So how many 1/3s are there in 2? There is 6. Okay? Now, again, there's another way to actually model this, okay? And here it is again. So let's do this model this time. I'm going to use circle models this time. So 2 divided by 1/3. It's still the same thing. It's still how many 1/3s are there in 2, except this time I'm going to take 2 wholes. And I'm just going to write this out the way the equation is written, even though even though these are circles. So here's my 1/3. Now it's asking, how many of this can I fit in here? Well, I have to actually try to make these guys look exactly like this fraction, so that'll make it more accurate. And so maybe it's easier to see it this way, but the assignment does ask you to use a number line. So how many of this shaded portion, which is, this is my 1/3, this is my 2, this is my 1/3, how much of this is actually in here? Well, you can count it. You can fit this in here 1, 2, 3, 4, 5, 6 times. There are 6 of these in here. 1, 2, 3, 4, 5, 6. The answer is 6, or better yet, 6. And the reason why I put it in quotes like this is because the answer for this really, even though we're using circle models here, I can't draw 6 circles over here. That's not what our answers are going to be. So in this case, it'll just be the statement 6 or the number 6, okay? So there's another model, okay? And there's the number line model. And now, let's just do the math. I'll show you how to do the math for this, the algorithm, just to see if we're actually correct. When we take 2 and divide it by 1/3, we should get 6 mathematically. So we're going to write this again. How is the math done for this? Well, first thing I do is write this whole number 2 as a fraction over 1, denominator 1. Now, here comes the part where hopefully I don't lose anybody. We're going to turn this equation into a multiplication, but we're going to turn this 1/3 over, or turn it into its called reciprocal, into 3 over 1. So this step right here is really called multiply by reciprocal. AKA, this reciprocal is also known as the inverse. In plain language, it's just called the turnover of this fraction. So really, all you're doing is multiplying by the turnover of this 1/3, which would be 3 over 1. And so from here, now we can just go ahead and multiply the numerators. 2 times 3, which is 6, and then 1 times 1, which is 1. Finish it off. 6 divided by 1 is equal to 6. And so thank God we did get the same answer. So we did it right. We did the model right. Okay? Let me show you another one where we actually reversed the order. And I did this also in class. So here's another example. Okay? And the example that I gave is pardon me. Let's try this one. 1/2 divided by 4. And we can still translate this into our math English. and translate it into how many, how many of 4 is in 1/2, or how many 4s is in half. More accurately, we can actually ask this as how much of 4 can fit in half. Well, what is that supposed to look like? Well, let's draw our number line. What's our whole number? It's 4. So we're going to count up to 4. 1, 2, 3, and 4. Okay? And so what is the fraction that we're using here? Well, it's using halves. So we're going to cut each of these in half. And it's asking how much of this 4 is in this half, because this is our half right here. And it's asking how much of this whole thing can actually fit in there. Well, if you look at this carefully, this whole thing is made up of 1, 2, 3, 4, 5, 6, 7, 8 halves. 8. I should write it like this. 8 halves. There are 8 halves in here from 1 to 4. How many can you fit in there? You can only fit one of them in there. So our answer should be only 1/8, because here's a half, here's a half, here's a half. You have 8 of them. Okay, all together you have 8, but you can only fit 1 out of the 8 in there. So our answer for this, 1/2 divided by 4, is equal to 1/8. Okay? So, and again, there's another way for me to be able to illustrate this. Let's say, here's my 1/2. And it's asking me how much of this 4 can fit in there. Well, again, I'd have to make them look the same. As you can see, in this circle example, you can actually see how many halves we have. We have 1, 2, 3, 4, 5, 6, 7, 8. How many of this can fit in there? Only one of these can fit in there. So only 1/8 can fit in there. You get what I mean? I hope. One of the 8. There's 8 halves in here. 8 halves. But only one can fit in there. Okay? So now, let's do the math. So 1/2 divided by 4. Let's see if this math makes sense. Okay. 1/2 divided by, write the whole number as a fraction over 1. Okay. And now we're going to do what step? Multiply by the reciprocal, or the turnover of 4 over 1, which is 1 over 4. Multiply numerator is 1 times 1. And multiply numerator, denominators, 2 times 4 is 8. And look, we were right. Only 1/8 of 4 can fit in a half. 1/8. Okay? So I hope this makes sense, and I hope this video helps you. And if you have any questions, just leave me a comment below in the comment section, and or my students, you can just go ahead and ask me in class. So thank you very much, and have a wonderful day. Bye-bye.